Hi, in this video, we want to take a look at marginal model plots. All right, marginal model plot is a special type of scatter plot that we use to basically assess our model quality. Okay, so the idea is that we're on the vertical axis, we're going to have our observed target variable variables, our observed target variable values, and then along the horizontal axis, we're going to have some data that we find to be very important. So for example, it could be the fitted values. That would be definitely an important one to go with. Or maybe we could go with a predictor variable. We could go with a linear combination of predictor variables or some other quantities that we can match up to our observations. Now, here's a part that it gets a little bit more interesting. What we're going to do, we're going to overlay our model onto there. So like a straight line for us, since we're doing linear regression. And we're going to put a smooth curve that follows the data points, usually a lowest model, for example, which in this class we haven't talked about yet, but we're getting to that shortly. Okay, what we want to do, we want to use the scatter plot and our model line and the smooth curve to check to see, do we have a good model? If we have an outstanding model, the smooth curve and our straight line will be very close to each other. And so we'll be feeling pretty good about our model. Okay, so for this example, what we're going to do, we're going to go through the standard linear regression process that we've been doing so far, session after session. Then we're going to take a look at the plots, the marginal model plots, and decide what to do from there. All right, so first thing I'm going to do, I'm going to load the data just like I always do. And then I always like to sort my data by like important variables. So I go ahead and I sort it by the predictor variable, then by the target variable. That way it's a little bit easier to spot trends as I work through different plots. And true to form, I go ahead and I define colors based off of the target variable. So, I don't have to do it off of the target variable, but, usually some variable that I believe is going to be very important. I'll do this for. All right, next, I'll go ahead and do a scatter plot. Remember, the scatter plot is my most important diagnostic for linear regression. And there's a mosquito flying right in front of me. Let's see if I can get it. Nope, didn't get it. Okay, well, this is going to have to bite me during the video. All right, so here's my scatter plot. So right off the bat, boom, I see that that does not look like a straight line to me. To me, that looks like kind of like 3/4 of a frowny face in a way. So initially, I'm thinking maybe a quadratic regression model might be the way to go. But let's go ahead and let's go through this example as if we're like, we don't believe that that's the way to go. We're going to do linear regression, then we'll do quadratic regression. All right, so let's go ahead and do regular old vanilla regression. All right, and we're taking salary as our target variable and experience as our predictor variable. And it looks like the intercept and the slope of experience are definitely not 0. And let's see if we scroll down a little bit more. Definitely some informative value coming off the F-test. But our R-squared and adjusted R-squared are rather weak. So we would like to have something a little bit better, but let's keep going. All right, yeah, our NOVA test shows us that things are, there's definitely utility in this model. Let's go ahead and look at our plots. All right, so remember, when I look at a residual plot, if I see a pattern, that's bad. I want it to look like a cloud, a random cloud of points just kind of scattered about. I see, to me, what looks like a pattern, a frowny face. So this looks more like a degree 2 polynomial than it does a cloud of dots. Therefore, I've got a problem. I'm going to need to fix it. Now, I'm looking at the normal QQ plot, and over here, it looks like I'm not going to have a normal distribution. So this tells me, now I would have to dig in deeper, look at the histogram. this is probably enough that I wouldn't really want to trust the p-values off of this. All right, well, here the square root of the standardized residuals. This isn't too bad. I mean, a little bit of an upturn on the far left, far right, but honestly, I wouldn't worry about this too much. What I find more concerning is that I see a bunch of points up, like up top, a bunch of points up top, and I don't see them down here. So I see like a cloud up top, and then things are kind of lower. So like this by itself would not be enough for me to throw up a red flag, but I would be kind of mindful of it if that was the first plot I looked at. Cook's distance. Okay, so we can see that the biggest three are kind of distributed throughout. And so this is like this plot in particular is why I sort my data, because if I didn't sort it, so these, this is in the order of the observations. And so if I just take the data as is, and there's a pattern related to some variable, it's going to be hard to see if Cook's distance is corresponding to a variable at all. And when I look at this residual plot, there is clearly a line going on. So like this smooth curve that's following the scatter plot, I really want that to just be flat. I want it to just kind of look like it's just kind of going around 0, and I don't really see like any pattern to it. Remember, residuals always add up to 0. At least in linear regression. That's not true in other model structures. And here's Cook distance versus leverage. Remember that I want to compare things along these contour, but at this point, I'm convinced that I've got a crap model, so I'm not even going to worry about this. I'm just going to move on and start building my model. Oh, actually, I'll go ahead and do the marginal model plot. So we know we have a bad model. Okay, so I know I have a bad model, but I'm going to use the fact that this is a bad model to show what we're looking for when we're diagnosing a model using marginal model plots. Okay, so this red line is our modeled line as I go through here. If I had a perfect model, then what would happen is that my data points and this smooth curve would follow my modeled line. Okay, so if I had a really good model, the red and the blue would be nearly perfect on top of each other. Now they're going to wiggle a little bit because where I have like sparse data, you're going to see a little bit more wiggle off of these smooth curves. But overall, as a whole, if I have a good model, the red and the blue are going to be tight together. And so will be the scatter points. All right, now that one, the x-axis was along the fitted values. What we can also do, we can have the x-axis go with a predictor variable. Now for us, since we're doing simple linear regression, fitted values and the predictor variable are going to just go along with each other. So really this is the same plot with different labels along the x-axis. But if I had more variables and I was doing multiple linear regression or quadratic regression, it would be more interesting what's down here. Fitted values and the predictor variable would not match up so well. Now, what I've done, I use the function MMP to make those two plots so far. What I can also do, so that MMP stands for marginal model plot. If I go MMPS, that's marginal model plots, plural, what it'll do, it'll generate a whole bunch of those plots for us automatically. So let's go ahead and do that. All right, so here we have fitted values and we have one predictor variable, so it creates two plots for me. And these really are the same plots, it's just that the x-axis is along different scales. But we can see that the red and the blue are not tied to each other. So this is how I use a marginal model plot to say, hey, I don't have a good model. The straight line and the smooth curve are not adhering to each other. Okay, so I looked at this and I said, hey, I think I need to do quadratic regression. I'd say, well, I only have one predictor variable. So quadratic regression is probably a good choice to go with. So all I'm going to do, just like we've done before, I'm going to add the identity function and I'm going to square the predictor in my formula, and then I'm going to go for it. And I see that the intercept, the linear term, and the quadratic term are all, the p-values are all within machine accuracy of 0. So I'm very confident that I've got, I've got good predictors going into my model. I noticed that, whoa, holy cow, look at the change in the R squared and the adjusted R squared. It went from like 0.6 to 0.9. Wow, that's a huge improvement. Huge, huge, huge improvement. So I'm feeling really good about this model. ANOVA supports doing a quadratic. And I'll go ahead and look at the diagnostic plots. And this pretty much looks like a cloud of dots. Now, the distribution is a little bit choppy, but that's because of the values that we have for the predictors. And that's not something I need to worry about. But you can see that there's kind of an uneven spacing of the fitted values. It's like all clumped up over here, then I get more gaps between the points that way. And that's okay. You notice how this line doesn't look like it's fitting a pattern. That's good. That's what I want to see. If I had random dots, this line would look either like horizontal or it wouldn't look like it's fitting any kind of pattern whatsoever. All right, I'm looking at the QQ norm plot, and I can see that it's deviating from the normal line. So here, I'll have to be worried about doing hypothesis testing. So this tells me, even though I've got a good fit, so I have a good fitting model, this is showing me that the normal distribution of the residuals is not, that assumption is not applicable to this model. What this means for us is that I can't trust p-values. Now, I can still trust, the predicted values. I can still trust like the slope, but I can't do hypothesis testing on the slope. So, but everything was the p-values were so close to 0 that honestly, if I'm doing like predictions or I'm trying to do inference off of this is okay. Now, if I needed to write an academic paper and they wanted p-values and they want hypothesis testing, then I might have some problems. But this is a good fitting model, and frankly, it's worth the loss. The hypothesis testing is used to give us the illusion of objective decisions. That's my opinion. All right, so now square root of standardized residuals. I'm not really seeing a pattern with that line. And it's okay for me to for there to be kind of that choppiness going horizontally, as long as it looks like a kind of a random cloud up and down. It's all good. Yeah, Cook's distance. I can see that 29, 7, and 41. Those are the entries that, and this will correspond to the original row order, because that's how the row names were established. But yeah, I'm not too worried about it because the model fits so well otherwise. Residuals versus leverage. I can see that I got a bunch of points here. And this is pretty small for the leverage, so I'm okay. And we can see that we don't even, we've got 2, and it's just about the largest contour goes along 2. So it doesn't reach 3. So I'm feeling pretty good about this. All right, so now let's take a look at the marginal model plots when we have a model that I'm feeling good about. Okay, so what I want to do on this first one, we've got the fitted values along the x-axis and the observed target variable values along the vertical axis. So here is the observed values, here are the fitted values. If I have a good model, this will look like the line y equals x. It will be along a straight line. And the scatter point, the points look like they're along a line pretty well, not perfectly, but they are close. I can see the regression line and the smooth curve, which is blue, are pretty close to each other. This is consistent with me having a good model. Let's go to the next one. All right, so now here I've got years of experience. Now remember, years of experience was in there twice, a linear term and a quadratic term. All right, so because of that, you can see that the model is taking a curve because I'm modeling with a quadratic. And we can see that the points and both lines are adhering pretty close to each other. So this is consistent with me having a good model. Now let's do MMPS, which plots all of my all the plots for us at once. So that I'm going to get all the plots at once, the marginal model plots. All right, so here I've got experience, and it's going along it that way. Everything's looking good. Here I've got the fitted values, which was the first one we looked at previously, and things are fitting pretty tight. Now here I have experience squared. So this is something we didn't look at previously. Now I'm looking at experience squared, and as I go along, yeah, that's looking pretty good. Maybe a little bit high at the very end, but you know, for this type of plot, that's okay. Smooth curves tend to wiggle a little bit at the far left and far right, and that's because there isn't enough input coming from each side. All right, well, that's all I've got for you. I hope you're doing well. Take care and goodbye.